Voyager 1 has traveled 22 billion kilometers over more than 40 years since its launch in the late 1970s. The question now is, how far can it go? Will this probe eventually reach distant star systems as humanity's first ambassador? And if so, could we receive an answer from there? The Voyager probes are considered milestones in space exploration, providing us with unprecedented images and data from the outer planets, places once thought to be the end of the mission, yet their journey continues today. Can Voyager 1 travel forever, and what will it encounter on this long journey? Voyager 1 flies at a speed of approximately 62,140 kilometers per hour, and it crossed the boundary of our solar system in 2012. It was the first man-made object to leave the heliosphere and enter interstellar space. Voyager 2 followed shortly after. Since then, the two probes have ventured further into the universe, each on a different path, with no one knowing exactly what they'll find. We can't predict if these probes will eventually be discovered by another intelligent species, one that, like us, explores space, and is surprised to encounter alien technology. The primary mission of the probes was to explore the outer planets of the solar system. In the 1970s, a rare alignment of planets made it possible to send the probes on a relatively short journey to the outer edges of the solar system. Even back then, there were clever minds at NASA who thought it might be possible to send a probe beyond the orbits of Neptune and Pluto into the Kuiper Belt, a region over 4.5 billion kilometers wide, home to billions of asteroids, comets, and several dwarf planets. In the 1970s, little was known about this distant area of space. It took the probes 12 years to reach the outer planets, and another 10 years to cross the Kuiper Belt. No one knew if they would survive the high risk of collisions with rocks or asteroids, but these space icons overcame every obstacle and completed every task set for them. For 45 years, the probes have continued on, eventually crossing into the heliopause, the region where the sun's influence diminishes, roughly 18 billion kilometers from the sun. Scientists call this the heliopause, characterized by the separation of solar and interstellar winds. Researchers are particularly interested in this area for its unique properties. When Voyager 1 reached the heliopause, 35 years had passed since its launch. No one expected the probe to travel this far, yet it is still going. As of April 5th, 2024, Voyager 1 was 2.39 billion kilometers from the sun, and Voyager 2 was 2.37 billion kilometers away. The question remains, where will they go next? And what new discoveries will researchers make as the most successful probes of all time continue their journey beyond the solar system? The shock at the edge of the solar system. It was a surprise when Voyager 1 was the first to cross the solar system's final frontier. The data transmitted from this transition was very different from what scientists had anticipated. Instead of a smooth change, as had been predicted by simulations, Voyager 1 encountered a thick wall, marking the boundary between the heliosphere and open space. This unexpected finding raised questions about the true nature of the interstellar medium, as all previous data had been speculative. Shortly after crossing this boundary, Voyager 1 provided real data from open space for the first time, and another surprise followed. Although the particle density dropped as expected, there were still more particles than anticipated. This likely indicates a different pressure ratio at the transition point, leading to a buildup of particles and radiation within the solar system, creating a dense wall. Voyager 2 later confirmed these findings when it crossed this boundary at a completely different location, showing that the end of the solar sphere is not gradual but rather hard and abrupt. The heliosphere serves as a protective shell for our solar system, formed by the sun's constant stream of particles, shielding us from harmful interstellar radiation. Researchers hope to learn more about the interactions between the solar system and the broader universe, as our sun is not stationary in space, but moves through the Milky Way galaxy, leaving traces in the interstellar medium. The Voyager mission has become humanity's first opportunity to explore this uncharted territory. Who would have thought that these two probes could last forever, becoming humanity's longest-lasting ambassadors? Engineers built the probes quickly and with a minimal budget, as a launch window only opens once every 176 years. The core of both probes is a robust, multi-sided structure made from aluminum and titanium, materials known for their resilience. This durable frame forms the backbone of the probes and has played a critical role in their success. The most striking feature is the large dish-shaped high-gain antenna, which has a diameter of 3.7 meters. Like a listening ear, it is always pointed toward Earth, enabling communication over vast distances. A signal from the Voyager probes now takes over 2 hours to travel, with radio waves moving at nearly the speed of light. These signals are received on Earth by the Deep Space Network, a network of 3 high-performance antennas located in California, Spain, and Australia. The Deep Space Network not only transmits signals from the Voyager mission, but is also used by NASA and other space organizations to communicate with distant probes and spacecraft. When the Voyager probes were launched, it was unclear whether radio contact would continue beyond the Kuiper Belt. The mission beyond the outer planets was a bold venture, and it's nothing short of a miracle that the connection is still stable, after more than 45 years and over 20 billion kilometers. The Voyager probes have already made an indelible mark on space exploration, and their mission is unlikely to be surpassed anytime soon. Of course, this long journey requires a propulsion system for navigation and course corrections. However, these are not conventional thrusters, but small hydrazine reaction wheels that stabilize the probes and allow NASA to precisely control their orientation in space. The probe's propulsion system can be traced back to the thrust generated by the rockets during their launch in 1977. The probes then accelerated using gravitational slingshots from the planets they passed. Voyager 1 received its final major boost at Saturn. Over the years, the probe's speed and direction have been adjusted using gravitational assist maneuvers, so they no longer need additional propulsion. Now they are in a state of free flight, meaning they continue their journey through space without needing active propulsion. They glide through the vacuum of space, largely unaffected by the gravity of the sun or other bodies, and this journey will continue indefinitely. Before speculating about where they might end up, let's take a look at the design and sophisticated technical equipment on board. Both probes are equipped with an array of scientific instruments, carefully positioned inside and above their bodies, well protected by their robust construction and special radiation shielding. These instruments have enabled the probes to study the dense phenomena of space for an astonishingly long time. From the first true color photographs of the outer planets to magnetic field measurements and analysis of interstellar particles, the engineering behind these probes is truly remarkable. It's almost like the old cameras that still function today, while modern digital cameras often fail after just a few years. Most of the measuring devices and cameras have been turned off to conserve precious electricity, which is supplied by radioisotope generators converting heat from plutonium-238 decay into power. These long-term batteries should keep the probes operational for another 5 years or so, after which they are expected to go silent, likely around 2030. NASA is preparing for the eventual loss of contact, marking the end of an era. So how far can Voyager 1 really travel? You've probably wondered where these probes will end up. Perhaps you've seen the 1979 movie Star Trek, where a strange superintelligence with an initially indecipherable radio message, Voyager, causes a stir. By the end of the movie, it's revealed that Captain Kirk and his crew have discovered an ancient human probe, which turns out to be a distorted version of Voyager. This scenario could someday become a reality. It's possible that one of the probes will eventually reach a distant star system and become stranded on a planet. However, it is far more likely that both probes will continue their journeys through open space on their current trajectories. It would take them thousands of years just to pass by the nearest stars. Calculations suggest they could encounter stars like Gliese 445 in the constellation Camelopardalis or Ross 428 in Andromeda. Most likely, the probes will continue their journey until they break apart in a few 100,000 or even millions of years. No one can predict how the radiation from interstellar space and temperatures around negative 273.15 degrees Celsius will affect the materials of the probes over time. Other stresses, such as sparse particle streams in space, may also contribute to their deterioration. Additionally, smaller rocks or micrometeorites could gradually wear down the probe's metal parts. The probes were bolted, riveted, and in some places welded. And so far, this construction has withstood the harsh conditions of space incredibly well. Experts believe that at the very least, parts of the probes will continue to travel through the universe as recognizable technical components millions of years from now. If humanity ever masters faster than light travel, perhaps we could one day encounter these probes in space, or they could be discovered by another species. Inside, they would find a golden record that explains who built the probes, how long they've been traveling, and where they came from. Maybe, just maybe, one day we'll receive a surprising message from the universe.